Hi everyone, so in this video we're going to be talking about probabilities involving the words and the word or. Okay, so first off we're going to talk about the word and. So if A and B are two events, then the probability that both A and B happen is going to be the probability of A times the probability of B. So it basically just means that you take the two probabilities and you multiply them together. Now, a note, unless otherwise stated, we always assume that event A has occurred when calculating event B. So to find probability of A and B, we first are going to determine the probability that event A occurs, and then that event B occurs. As in, order does matter. And that won't matter for a bunch of these, but for some of them it will, and in number 2 we're going to see that. Okay, so starting off easy with a spinner again. So if the spinner to the right is spun twice, find the probability of spinning 2 blues. So we can think of that as the probability of getting blue and another blue, which just means we're going to take the probability of getting blue and multiply it by the probability of getting blue. So for this spinner, since there's 4 options, the probability of getting blue is 1 out of 4. And the second time it's going to be the same thing. It's still 1 out of 4. So if we multiply those together, we get 1 out of 16, and that is our answer. All right, let's look at some cards. 2 cards are to be selected from a deck of cards. Find the probability of selecting an ace and a king if the cards are selected A with replacement or B without replacement. Okay, so let's look at with replacement first. So with replacement means that I'm going to select the card, I'm going to look at it, I'm going to put it back in the deck, I'm going to shuffle up the whole deck, and then we're going to pick our second card. Okay? So if we want the probability of getting an ace and a king, then we're going to multiply those 2 probabilities together. The probability of getting an ace is 4 out of 52 times the probability of getting a king, again 4 out of 52. So if we multiply these together and reduce the fraction, we get 1 over 169, or approximately 0.0059. Again, probabilities can be fractions or decimals. Just make sure you read the question and see which one it wants and give it the correct answer. All right, that one's easier than without replacement. So without replacement means we are going to pick the first card, we are going to rip it up, we're going to throw it away, we are going to burn the little pieces, that card is gone. Then we are going to select the second card from the rest of the deck without that first one. Okay, so we're going to start this out the same way. We're still going to be multiplying these 2 probabilities. And even the ace, it's going to be the same thing, 4 out of 52. Now here's where it differs. As soon as we select an ace, let's say that it was the ace of spades. The ace of spades is now gone. Which means when we are doing our second probability, we have 4 kings out of the 51 cards in the deck. There's only 51 cards now because one of the aces is gone. So we only look at the 51 cards that are left. And this is going to change our probability a little bit. So this is going to give us 4 out of 663, or approximately 0.0060. So as you can see, this one's a little bit more likely. Without replacement, it's actually a little more likely to get an ace and then a king, because for the king, there's less cards that you're picking from at that point. Alright, so a quick definition before we move on. Two events, A and B, are independent events if the occurrence of either of them has no effect on the probability of the other. So, for example, if event A is rolling a die and event B is flipping a coin, the events are independent. If you roll a 4, then that doesn't affect the outcome of the coin flip at all. Events that are not independent are something like if 2 cards are selected from a deck without replacement. Those are not independent because once you take that first card from the deck, you're changing how many cards are left, so the probabilities do change. Alright, so with that out of the way, let's go ahead and do some more of these. So if a coin is flipped twice, what is the probability of getting 2 heads? Now, we've already done this one before, and the way we did it was we just wrote out the whole sample space, and we saw that it was 1 out of 4. Well, what if we were flipping 10 coins? We wouldn't want to write out that whole sample space. That's over 1,000 different things in that sample space. So we don't want to have to write all of that out. Instead, all we're going to do is we're going to think of this as the probability of getting heads and another heads, which means we just get to multiply these probabilities. So the probability of getting heads on just one coin is 1/2 times 1/2 again for the second coin, which gets us the 1/4. Again, for 2 coins, maybe it is easier just to go ahead and look at the sample space, but for something like 10 coins, this way is going to be a lot easier because you get to just multiply them out instead of writing down a sample space with over 1,000 elements in it. Alright, if a couple has 3 children, what is the probability that they will have 3 boys? So keep in mind, for this one, we're going to assume that the probability is 50-50 to get a boy or a girl, just to make this problem a little bit easier. So we're going to think of this as the probability of getting a boy and another boy and a third boy. So it's going to be the probability of getting a boy times the probability of getting a boy times the probability of getting a boy, which we just said it's 50-50, so it's 1/2 for all of them. Which is going to get us 1/8. Alright, if we draw 2 cards from a deck without replacement, what is the probability of choosing 2 aces this time? So we want the probability of getting an ace and another ace, which is the probability of ace times the probability of an ace. So for the first ace, it's going to be 4 out of 52, just like normal. But again, now we just took one of those aces. So let's say it's the ace of diamonds that we took. That means the ace of diamonds is no more. We only have 51 total cards left. And in addition to that, we only have 3 aces left. So the probability that we get the second ace is now 3 out of 51. Multiply those together. We get 1 over 221. All right, the following results were based on a recent survey conducted by Professors Kurian and Watson. So a group of 50 students were asked whether they would try an Oreo dipped in orange juice. About 24 of the 50 students said yes, that they would try it, and about 3 out of 8 who said they would try it thought that they would actually like it. So, we're going to find the probability of first choosing someone who said that they would not try it. Okay, so this one we don't have to worry about doing an and probability, because for this one we're just trying to figure out people who wouldn't try it. That's one thing that we're trying to figure out. So if 24 people said yes, then that means the other 26 said no. So 26 out of 50, or 13 out of 25. For part B, that they said yes, they would try it, and that they liked it. So this is the probability of yes, they would try it, and that they would like it. So that's going to be the probability that they said yes times the probability that they liked it. Probability that they said yes is just 24 out of 50, because 24 students said that they would say yes. And for the probability that they would like it, 3 out of 8 said that they would like it, so that's 3 out of 8. Multiply these together, and we get 0.18. Right? Or as a fraction, probably should have wrote the fraction first, 9 over 50, or 0.18. All right. So that's and. Now let's look at or. So if A and B are two events, the probability that A or B happens is the probability of A plus the probability of B minus the probability of A and B. Okay, now that's kind of confusing, so here's the way I like to put it. It's the probability of A plus the probability of B minus the overlap. So you'll see what I mean in a second, but just keep that overlap part in your mind. So let's go ahead and do an example. If a die is rolled, what is the probability of getting an even number or a number that is greater than 4? So remember, normal die, numbers 1 through 6. So we want the probability that is even or greater than 4, which is going to be the probability that it's even plus the probability that's greater than 4 minus the overlap. Okay, so let's do these one at a time. Probability that's even. There are 1, 2, 3 even numbers. So that's 3 out of 6. Probability that's greater than 4. There are 1, 2 numbers greater than 4. So plus 2 out of 6. Now what I mean by overlap is we accidentally just counted one of these twice. So you can see that there were 4 numbers that fit at least one of these two. As in, there's 4 numbers that are either even or greater than 4. But right now, if we just add these up, we would get 5 out of 6. Well, we know that's wrong because 1 is not even or greater than 4. 3 is not even or greater than 4. That's where the overlap comes in. We're getting a higher number than we should because we accidentally counted 6 twice. Notice that it has both a green and a red dot. So, since we counted it twice, we have to subtract out that extra one that we counted. So there was one of them that overlaps out of 6, meaning that 6 is a number that is both even and greater than 4. That's why it's the overlap. All right, so once we do that, we just get 4 out of 6, or 2/3. All right, let's try with the deck of cards. If one card is selected from a deck of cards, what is the probability that an heart or an ace will be chosen? So probability of heart or ace. So that's going to be the probability of getting a heart plus the probability of getting an ace minus the overlap. So let's do these separately first, and then we'll talk about the overlap. So probability of getting a heart. Well, there are 13 hearts. There are these 13 right here. So that is 13 out of 52. Plus, probability of getting an ace. There are 4 aces. So that is 4 out of 52. Minus, is there any overlap? So is there any card that is both a heart and an ace? Well, yeah, the ace of hearts. This one right here. So there's one card out of 52 that fits both criteria. So we are subtracting that one out. So this is going to be 16 out of 52, which if we go ahead and divide those by 4, we get 4 out of 13. All right, or probabilities with mutually exclusive events. So mutually exclusive just means that it's impossible for both events to happen at the same time. So mutually exclusive could be a die is rolled once. If event A is rolling a 3 and event B is rolling a 6, the two events are mutually exclusive, meaning that you can't roll both a 3 and a 6 at the same time. You're only ever going to get one number on a die. So those are mutually exclusive. Not mutually exclusive just means they do have an overlap. So that'd be like if you rolled that same die and we said an even number or rolling a 4. Well, 4 is an even number, so there is an overlap there. So those are not mutually exclusive. So if two events A and B are mutually exclusive, then it means you can just add their probabilities. Now, with that said, don't worry about this too much, because in the end, this is just saving you some time, if you notice, because that overlap is just 0. It's the same exact formula, just for mutually exclusive events, the overlap happens to be 0. So if you always use the regular OR formula, then it'll still work for mutually exclusive events. You'll just have 0 for the overlap. That's what I'm going to do the majority of the time. I'm still going to put minus the overlap. And if it happens to be 0, we'll know they're mutually exclusive, so no big deal. All right, so let's go through some more examples. If a die is rolled once, what is the probability of getting a 1 or a 6? So the probability of getting 1 or a 6. Now keep in mind, this one is going to be mutually exclusive because you can't get a 1 and a 6 at the same time. So you could just do probability of a 1 plus probability of 6 and leave it there. But I'm going to go ahead and say minus the overlap, and it'll still work just fine. So probability of getting a 1 is 1 out of 6, plus the probability of getting a 6 is also 1 out of 6, minus there are 0 ways to get a 1 and a 6 at the same time. So minus 0, which is going to get us 2 out of 6, or 1/3. Alright, if one card is selected from a deck of cards, what is the probability of selecting an ace or a jack? So probability of ace or jack. It's going to be the probability of getting an ace plus the probability of getting a jack minus any overlap if there is one. So the probability of getting an ace is 4 out of 52, because there's 4 aces, plus probability of getting a jack is also 4 out of 52, minus, are there any cards that are both an ace and a jack? No, it can't be both an ace and a jack. It's one or the other, so 0. This is going to be 8 over 52, or 2 out of 13. All right, a single die is rolled one time. Find the probability of rolling a 3 or a 4, or an odd number, or a number greater than 2. All right, so starting with a 3 or 4. It's going to be the probability of getting a 3 plus the probability of getting a 4 minus the overlap. The probability of rolling a 3 is going to be 1 out of 6. Probability of getting a 4, also 1 out of 6. And since you can't get both a 3 and a 4 on the same die roll, minus 0. So that's 2 6, or 1/3. All right, an odd number or a number greater than 2. So probability that it's odd or greater than 2. It's going to be the probability that's odd plus the probability that's greater than 2 minus any overlap. All right, probability that it's odd. So 1, 3, and 5 are all odd, so that's 3 out of 6. Probability that's greater than 2, that would be 3, 4, 5, and 6, so that's 4 numbers out of 6. Minus, are there any odd numbers that are greater than 2? Yeah, 3 and 5 are both odd and greater than 2. So we counted them both twice. So we're going to subtract 2 out of 6. All right, so add those up, and we get 5 out of 6 as our final answer. All right, back to playing cards. So one card is selected from a deck of playing cards. Find the probability of selecting a jack or a diamond, and then a club or a red card. So first off, probability of jack or diamond is going to be the probability of getting a jack plus the probability of getting a diamond minus the overlap. The probability of getting a jack is 4 out of 52. Probability of getting a diamond is 13 out of 52. And then are there any overlap? Are there any cards that are a jack and a diamond? Yes, the jack of diamonds. So that's minus one card that is an overlap, which is 16 over 52, or 4/13. Next up, a club or a red card. So probability of a club, or red. It's going to be the probability of a club plus the probability that it's red minus any overlap. Probability that's going to be a club is 13 out of 52. Probability that's red is 26 out of 52, because half the deck is red. Minus, are there any clubs that are red? No. All of the clubs are black cards. None of them are red, so there's 0 overlap. So that's going to get us 39 out of 52, or 3/4. All right, back to the survey for a couple questions. So a group of 50 students were asked what social media platform they used and how long they spend on social media. The results for the one used most are below. So we're going to find the following probabilities. For part A, someone who is a freshman or prefers Instagram. So we're going to do probability that they're a freshman or Instagram. So to do that, it's going to be the probability that they're a freshman plus the probability that they prefer Instagram minus any overlap. All right, so for this one, if we look, we're going to do freshmen first, and all we're going to do is look at the total at the end. There's 37 freshmen, so that's 37 out of 50, plus for Instagram, that's this column right here, and there are 14 people total who prefer Instagram. So that is plus 14 out of 50 minus, is there any overlap? Yes. The 12 right there was both in the freshman row and the Instagram column. There's 12 people who are freshmen that said Instagram. Those 12 are both. So that's the ones that we counted twice, so we have to subtract those out. So if we do that, we're going to end up with 39 out of 50. All right, what about a sophomore or prefers YouTube? So this is going to be the probability of sophomore or YouTube, which is the probability of sophomore plus the probability of YouTube minus the overlap. All right, for sophomore, there are 13 sophomores, so that's 13 out of 52, plus for YouTube, there's 9 total people who preferred YouTube, so that's plus 9 out of 52, minus there was 2 people that were in the YouTube column and the sophomore row, which means there's 2 people in the overlap. I'm sorry, I'm saying 52. It is out of 50 students. I accidentally reverted back to cards for a second, but these should all be out of 50, not 52. So if we add all of those up, we get 20 out of 50, or 2/5. All right, selecting a freshman or prefers YouTube. So probability that they are a freshman or prefers YouTube. It's going to be the probability that they're a freshman plus the probability that they prefer YouTube minus any overlap. Okay, so probability that they're a freshman. It's going to be 37 out of 50. Probability that they prefer YouTube is 9 out of 50. And then there are 7 in the overlap. So minus 7 out of 50. Oops. So that's going to give us 39 out of 50. And that's our answer. All right. In the office, Kelly was asked whether she would choose 1 hour of nap or 1 hour of TV. Rachel was curious as to what her students would say, so she decided to ask them whether they would choose 1 hour of nap or 1 hour of TV. The results are below. So first was the probability of choosing someone who is a freshman or chose TV. So probability that they are a freshman or chose TV is going to be the probability that they're a freshman plus the probability that they chose TV minus any overlap. So probability that they are a freshman, that is going to be 37 out of 50. Probability that they preferred TV is going to be 20 out of 50. And there's 15 in the overlap, so minus 15 out of 50. Add all of these up, and we're going to get 42 out of 50, or 21 out of 25. All right, what is the probability of choosing someone who chose nap or TV? We go about this the same way. Probability of nap or TV. So first off, we are going to split that up. So probability of nap plus probability of TV minus any overlap. So for nap, it was 30 out of 50. For TV, it was 20 out of 50. Now in this case, there's no overlap. There's nowhere that the yellow and blue touch. So, minus 0. Add those up, we get 50 out of 50, or 1. Which makes sense because we didn't give them any other options, so everybody had to pick one of those two. All right, last example. 2 professors had differing opinions about eating kangaroo meat. They decided to poll their students about whether they would eat kangaroo meat. The results are below. So for parts A, B, and C, go ahead and try the same thing that we have been. It's going to be very similar for A and B. They're just normal probabilities, and then part C is going to be the OR probability. So go ahead and try A, B, and C. Pause the video if you need more time, and the answers are going to pop up now. And here are the answers to these three. All right, with that, that is the end of these notes. If you have any questions, make sure to let me know. Otherwise, that is it. Thank you for watching.